Brain Access Solutions.
Hi, I'm Glenn of Brain Access Solutions. Welcome to my vlog. Welcome also to my C#.NET tutorials for beginners. And we are now at lesson 15. In this lesson, we will learn something about LINQ, or the Language Integrated Query. LINQ is a powerful feature in C#.NET. It allows you to query collections of data and lists, like the generic list that we've been making for the past few tutorials. LINQ is very similar to SQL syntax or TSQL, but the difference is it is directly integrated into C#.NET environment. Actually, it allows you to perform operations like filtering, sorting, or grouping up a list. Grouping up data from the list or from an array. And it can also query the database records. And the syntax will feel like you're writing SQL queries or SQL queries. It is fully integrated in C#.NET. So LINQ has two types of syntax styles. One is the query syntax, which is the same or similar to SQL or SQL-like syntax, and the other one is the method syntax. We're going to use the .NET Fiddle.NET for trying out the LINQ. The first LINQ type that I'm going to show is the query syntax. And we're going to begin with the simplest form of querying a list. This time we're going to create a list which has numbers from 1 to 9. Let's begin. As you can see from here, the list keyword is being highlighted by a wavy red underline. That's because we're not using the proper namespace for this. So currently we are just using the system namespace, and that is not enough to let us use other keywords like the list. So in this case, we're going to use the system collections generic. Let's type it. Okay, now that we have added this new namespace, the red underline has disappeared. That means we can now use the list keyword. What this thing does is that it creates an array or a list of numbers from 1 to 9. Now, what we wanted to do is to show all the numbers in this list by querying them with a LINQ or the LINQ. So to do that, here's what we're going to do. After writing this query or our LINQ query, as you can see, the numbers is now being highlighted with a red wavy underline. That's because we're not using the correct namespace again for this. We should add the system LINQ. So what we would like to do from here is to collect all the numbers. Get these numbers and show it. So we're actually using the LINQ query to get all the numbers. Okay, so here we're actually declaring the my numbers as the IEnumerable int collection that will hold the result of the LINQ query. This is the LINQ query from number in numbers, select number. So what we're trying to do here is create this IEnumerable collection to hold this query. Okay, so this number here will represent each item in the numbers. These are the numbers, the list inside the numbers, and this variable number will represent each item in the list. So for example, if we have 1 to 9 elements, so we will have 1 to 9 rows, so 1, 2, 3, 4, 5, 6, and so on. Then this number variable here will represent each row or each element. Since we have collected all the numbers and we didn't put any conditions like where clause, then select number will return all the numbers. But unlike the SQL queries which returns right away the result, here we can display the result using these commands alone. We will have to either use the same way we displayed the generic list before in our previous lessons, or we can do some reiterations or looping. We can do some loop to display the results, like using the for each command or the for each control statement. Since we have assigned the variable myNumbers as the collector for LINQ query, then we can just go ahead and reiterate the contents of this myNumbers using this num for each item in the myNumbers collection. And then for each instance inside the for each loop, we're going to write the value of the variable num. Compilation error. Okay, it says here that the console does not contain the definition. Okay, let's run the code again after fixing. So the next time we be mindful of how you write the spelling of each keyword, because one mistake could result in an error. As you can see from here, I have typed the right line as a small letter and it's actually giving us an error. But the correct syntax is right line with a capital W and capital L. So let's run the code. Okay, as intended to show, it's actually showing now all the numbers in the list by row. So we have 1, 2, 3, 4, 5 up to 9. This is how we query a generic list, an array or a database using the LINQ. And this is its very basic form. The LINQ could go more complex than this, and don't worry about that, because as we progress in our tutorial, we will cover all of the LINQ commands that we can use for C#.NET programs. And as you may notice, I am incorporating both traditional programming for C# and the more advanced, which is the LINQ way of handling data in C#. I'm also incorporating a bit of statistics and probability in our tutorials so that we are actually tackling real-life scenarios. Okay, so another thing of showing the result can be by, let's just comment this out. Commenting the keywords can be as easy as adding double slashes, and the compiler will ignore it and treat it as a comment. Another way to display the result is by using the string.join, which we've been using in the past tutorials. This is what I noticed with the online C#.NET compiler, .NET Fiddle.NET, is that sometimes the reaction time of it after correcting some mistakes will take some time, unlike the Visual Studio environment where once you've corrected something, the result will just come out really quick. You'll have to wait a few seconds for the changes to take effect. In our previous lessons, we highlight the use of string join. This string join accepts two parameters. The first parameter is the separator. In this case, we're using the environment new line, which is equivalent to pressing an enter key. And here's the myNumbers. I'm just going to join all of these separate elements into one long string, but we're actually splitting that resulting string into a string with a separator, which is the line carrier feed. So once we run this code, it will display this list into separate rows. Let's run. There you go. So now it is displaying items from 1 to 9. The beauty of using LINQ is that we can actually make filtering with it. If we wish to get only even numbers from this list, we can add a where clause and get only those numbers which are even. Okay, so the .NET Fiddle.NET is saying that this is an error, but nevertheless, it's actually showing the correct result. So The code we have created here is actually correct and it is defined in the collection, but the .NET Fiddle interpreter is having a misunderstanding about the where clause in LINQ. And we can just ignore this error because it's actually giving us the result that we're intending to see. The percent sign that we're seeing here is the operator for the modulus, and the modulus requires two items for it to work. The first is the number, which is this one, the variable that holds each item in the collection, and we're going to divide that with 2. So 2 is the divisor and the number is the dividend. So modulus is like dividing these two and finding out the remainder. So if the remainder is 0, then the items we're collecting is even. For example, the resulting numbers are 2, 4, 6, and 8. When you divide these items by 2, you'll get 0 remainder. For example, 2 divided by 2 is equal to 1, and therefore there are no remainders. That goes the same with the number 4, which is divisible by 2, 6, and 8, all of which are giving out 0 remainders when divided by 2. What if we wanted to just get all the numbers higher than 5? Okay, so the result is 6, 7, 8, 9. It's because we're using the logical operator greater than. If the number is greater than 5, then we can get 6, 7, and 8, and 9 result. Okay, so that's all for the query type syntax. So another type of syntax for LINQ is the method syntax. So let's go ahead and delete this or highlight this one. Okay, here we'll just comment these codes out. So once we commented them, we can just ignore and write the new codes below them. The method syntax in LINQ is known also as the Fluent syntax. It is an alternative query syntax and uses method calls. So method calls is like void main, like this. These are the sample method calls. Methods inside is like .where, .select, or .order by. Those are the methods that you can use in C#.NET LINQ. And there are so many methods that you can perform using the LINQ. But for now, we're just going to use the very basic order by. So let's run this. This is the method syntax of the LINQ, and it's the same as this query syntax without the where clause. Instead of writing the LINQ syntax like SQL syntax, the method for this LINQ is the select method. The select method is accepting 1 parameters. In the overload select query, this can be allowed to get 2. The lambda expression and the index. So this lambda expression can be changed into a different type or a different name. We can also put n and it will still work. But you cannot change this to m because it will no longer work. When creating a lambda, it is important to remember that the first variable name is the same as the second. So we can actually name this as the end result. The end result is just the name for the variable representing each. It's similar to this here. From number in numbers, here we're using end result in place of the number. As this select reiterates or go through each element, the end result is the variable for holding each element in the list. And the equal to or greater than is not the same as the logical operator equal to or greater than, but in C# LINQ, this is what we call the lambda expression. And this is the operator for saying that this will go to this, or goes to, or maps to the end result. So why did we have another end result after the variable end result? This is the way they designed it. The reason why we see end result again after the lambda operator is that it's going to represent the value of the expression. So after we declare this variable to represent each number, it will be transferred to this another parameter. So it's like saying for each element in numbers here, for each element here, each number, use this value to assign it to this end result. In other words, this is the result after the output of the lambda expression. So let's run it again. There you go. So the lambda expression can be also manipulated by you. For example, if we wanted to double its result per reiteration, we can do like end result, which means the value that goes to this one will be doubled because we're just adding end result to itself. Let's run it. Here you see that the number 1 becomes 2 because we added both the resulting value from this. The next one is to double it and it becomes 4, and it goes on to the next line or to the next element. What we're trying to prove here is that the output can be manipulated, but you cannot manipulate this part here. For example, plus end result. It will throw in an error because the LINQ is not designed that way. We can also add just 1 to each result and see what will happen. There. The maximum number now goes to 10, or its last element, because we're adding 1. And the beginning is now number 2 because we've added plus 1 to the first value. Okay, now the question is, how are we going to use the where clause in method style or method syntax? So we're just going to modify this. So instead of directly adding the select after the numbers, we're going to add the where clause here. If we wish to get only the numbers greater than 5, we can write it like this. Okay, let's run. So let me explain this a bit. It's still the same, except that in method syntax for LINQ, the where clause will come first. We're actually using 2 lambda expressions. One is in the where clause, where we assign the end result to end result, which is greater than 5, and get all the result after assigning this to this. So as you may notice, the lambda expression here is similar to the lambda expression in the select method, but actually they are a separate thing. You can actually change this name, this variable, into a different name as an output, and this will still work. There, 6, 7, 8, 9. We can change the number to see if this expression to change the result. You can have different names in each clause, but you cannot interchange the variables from different clause, like for example here, and this will not work. In essence, I feel like the method syntax looks more complicated than the SQL or the query syntax. If you're used to writing queries in SQL, you may find that the query syntax is much easier to read. But if you're more familiar with the C#.NET syntax, the method syntax or method type will be more easier for you to read. the select statement can only have one parameter, but in the overload query, the dot select can have two parameters. We can include the index number of each row in the overload query. What is the importance of adding the index of per element in the overload select query? We will actually use that in our next video, and I'm going to show you why the index is also important. So for now, I'm just going to increase the number of the greater than sign, the logical operator. Let's just put greater than 20 so that we can collect all the numbers in the list. And the output now will have the index. Okay, so here, I'm just going to explain this code a bit. Here, we're declaring the number, my numbers, as the holder for our list. So the variable will hold the collection of the numbers list here. The select close now has two parameters, and we call this the overload type. It is now requesting for the variable which will hold the value for each element, and the index which will hold the value for the index. We can actually name the index in any name, and it doesn't have to be the word index. And it will still work. Apple is equal to 0, but instead of index, it's now showing the word apple, which might be confusing to other people. So we're just going to name it back to index to make it clearer. So again, the index is for finding out the number of each element. The value for each element is here, shown here on the first column, while the second one is for its index. And in C#.NET, the index will always start from 0 and not from 1. So in essence, it is called the zero-based index. Okay, that's it for our today's video. I hope you learned something from this tutorial. If you find this video useful, please hit that like button, and please do subscribe to my channel. Leave your comment at the comment section below. Thank you very much for watching. Have a nice day, everyone. Goodbye.